Okay, today I'm going to discuss electrolysis of aqueous copper sulfate using platinum electrode. Now, for copper sulfate to conduct electricity in the solid state, it will not conduct electricity. So therefore, we dissolve it in water so that it is in the aqueous state. Okay, and the electrode that we are using is platinum electrode. Okay, as soon as you connect the two electrodes to the two terminals of the battery, again current starts flowing, and as soon as the current starts flowing, copper sulfate will dissociate, give us copper ion and sulfate ion. Likewise, since it is aqueous copper sulfate, so water also ionizes and gives you hydrogen ion and hydroxyl ion. So at the cathode, if you look at the two positive ion, the copper ion and the hydrogen ion, okay, both cannot be accepted by the cathode. So whichever is placed lower in the electrochemical series, it is the copper ion which is placed lower in the electrochemical series. So that will be accepted at the cathode. So at the cathode, the copper ion will go, it gains 2 electrons, changes into copper atom. Likewise, at the anode, whether the sulfate or the hydroxyl will be accepted, it is the hydroxyl which is placed lower in the electrochemical series that is going to get accepted. So at the anode, the hydroxyl ion will go, it loses 1 electrons, changes into hydroxyl OH, and 4 OH will combine together to give us 2 molecules of water and 1 molecule of oxygen. Now we come to the observation at the cathode. At the cathode, we see a reddish brown metal getting deposited, and that is copper. And at the anode, the observation would be we see a colorless gas getting evolved, and that is oxygen, which rekindles a glowing splinter. So this is the electrolysis of aqueous copper sulfate using platinum electrode.